All right, let's do a few more examples. See example 3. How many moles are in 2.0 liters of a 1.5 m solution? So again, real quick, if we're going to identify what we have, they're asking us how many moles. So we're going to be looking for moles. And they're giving us volume. And they're giving us molarity. Okay. We have the formula, right? M equals mole over volume, or liters, whatever you want to call it. Here we have to be careful, right? Because we're going to be, I'm going to do V for volume. We have to rearrange the formula so that we can find moles. So how are we going to rearrange this? Well, we need moles by itself, right? This guy here, we need him by itself, or it by itself. We need to get rid of volume. It's being divided by. So we're going to be doing the opposite. So what's the opposite of division? Multiplication. So we're going to multiply V to both sides. Cancels these. And we get mole is equal to V times M. Or M times V. It doesn't matter because since it's being multiplied, the order doesn't matter. So now we can plug it in. So we get mole equals 2.0 liters times 1.5 m. So we get moles to be 3. 3 moles. 3.0 moles. Remember, we want you guys to have your answer in one number after the decimal. Okay? Example 4. What volume is needed for 1.0 mole to make a 0.25 molar solution? So here I want you to try this problem on your own. So go ahead and try it with the people next to you and then double check your answer. Alright, so after you try it out, right, you identify the information that you're given, so moles, molarity, and we're looking for volume. And you'll have to rearrange. And so what you'll have to do is you'll have to rearrange the formula so that you're looking for volume. Sorry, this baby wanted to get held. You're going to rearrange this formula, so you're going to be looking for molarity, so you're going to rearrange the formula. And in order to rearrange the formula, you're going to be switching out molarity and volume, and you end up getting 4.0 liters. All right, and let's finish up with this example. We are going back to stoichiometry, but not full on, okay, just a little bit where you have to do some conversions from grams to moles, moles to grams, etc. So here, it's asking us how many moles are in 36.0 grams of H2O2. Find the molarity. So, what are we going to have to do first? And I'm going to write the steps here in case you need them. Okay, so steps. So the first thing you're going to do is they're asking you for moles. And they're giving you grams of H2O2. So what are you going to have to do? You're going to have to find the molar mass of H2O2 because we're going to have to convert from grams to moles. So you're going to have to find molar mass for H2O2 using your periodic table. So using the atomic masses from the periodic table, you're going to be converting those 36 grams to moles of H2O2. But first, let's find the molar mass. So a little recap. So we have hydrogen and oxygen, right? You're going to go to the periodic table and you're going to look for those elements, and underneath those elements, that number with the decimal point, that's the atomic mass. So if you look for hydrogen, it's 1.01. And if you look for oxygen, you're going to see that it's 16.00. And now you have to look at the formula that we got here, right? So this one right here, H2O2. You have to take into consideration how many you have of each. So you have 2 hydrogen, and then you have 2 oxygen. So you're going to multiply each of those by 2, and you get 2.02 and 32.00 here. Okay, so when you add those up to get the total mass, you're going to get 34.00. That is your molar mass. Okay, that is your molar mass. Now what you're going to do is you're going to convert grams to moles. How are we going to do that? Remember, to convert grams to moles, you do given grams times 1 mole over the grams. This here is your molar mass from the periodic table. Molar mass from periodic table. Okay, so if we were to plug this in, we do our given grams, which is this part right here. This is our given, okay? So we're going to do 36.0 grams of H2O2, and then we're going to multiply 1 mole H2O2. We're not going to a different substance or chemical, so we can keep it like that. And the molar mass, which is what we got here, this guy here. This 34 is going to go underneath. 34.00 grams of H2O2. Okay? And now all you have to do is you multiply across. So you can multiply 36 by 1 and then divide that by 34. And when you do that, 34.02. Sorry, I just noticed I messed that up. 34.02. Let me fix that over here. 34.02 grams of H2O. Okay, so when you do the calculations, you're going to get 1.058 ... But we want to keep it in 1 decimal form, so we want to keep one number after the decimal. So it'd be 1.1 grams, moles of H2O2. Now that we have our moles, right, we can go ahead and find molarity. Oh my gosh, I didn't realize that. Find the molarity. So go ahead and add this here. Find the molarity of this dissolved, because I was like, wait, we don't have volume. 2.0 liters. So now we can find molarity. So 3, find molarity. So let's plug it in. Molarity equals moles over volume, or liters. So we have our moles here. So 1.1 mole. And then we're given our volume on top here, 2.0 liters. And so we're going to divide that. And what do we get? And when you divide that, you get 0.55. We're going to keep it to one number after the decimal, so we get 0.6 m. And that's going to be your answer. So when you're doing these, remember, you're just going to do simple one-step conversions here. You're given grams, and then your molar mass from the periodic table. That's probably the most work you have to do. Okay, if you have any questions, please let me know.